So not all functions have an inverse. There are certain criteria that has to be met in order for a function to have an inverse function that is out there. And that's what we're going to learn a little bit about the criteria. So it's not something that we can just go ahead and blindly solve for. Like I had an example come up in my calculus class just an hour ago where they had to take the derivative of the inverse function, and so some of them were thinking about doing what I got ready to teach. I'm like, hey, you're going too far. One, because you can't really find the inverse based on this criteria here. And so we need to use the calculus principle in order to find what we're looking for, not go back to Algebra 2 and work our way through stuff. So when we look at criteria for inverse functions, first they got to be one-to-one. Well, what does it mean to be one-to-one? Well, a function is considered to be one-to-one. Don't worry about that injective. If two different inputs produce the same output, okay? Two different inputs, so two different x values give us the exact same y answer. That's what that's saying. Two different x values give us the same y answer. That's what that's saying there. So if you want to write that in, we write that in there. This means that two different x values give the same y answer. Oh, sorry, no two different. No, I forgot that's a big word there, isn't it? No two different. Big star there. No two different. Rewind my video. No two different x values. So you can't have two different x values. So put that word no in front of my little thing there. No, big old red no. No two different x values can give you the same y answer. So that's one thing you can do. Now, what you could also do is you can use what's known as the horizontal line test.
Steven?
Yes, ma'am.
I need Allison Mooneyford to send it to the annex office.
Yes, ma'am.
Thank you.
Yep. You can use the horizontal line test. What did we use the vertical line test for back in middle school? What? Yeah, is it a function? We did a vertical line test and we said, hey, if you touch my vertical line more than once as I go across x values wise, I know I'm not a function. Well, the horizontal line test is kind of the same thing. If I do a horizontal line and I start bringing it down vertically, or up vertically, doesn't matter. If I touch on that horizontal line my graph twice at any y value, then I'm not technically, I don't have an inverse, is what it says. Is I have to only touch that horizontal line once for it to have an inverse function. So when I think about some graphs we have dealt with already this semester, y is equal to x cubed and y is equal to x squared. The one on the left is my disco graph. The one on the right is the shape of a U. And then we think about, okay, if I bring a horizontal line and I bring it down through the thing, draw horizontal lines, I'm only touching that x cubed graph once. So that tells me that this passes horizontal line test. So it has an inverse. Whereas if I do the same thing with the x squared graph and I take a horizontal line and I start coming through, I notice that it's touching it more than once. And so we fail the horizontal line test. So we do not have a inverse or an inverse. And that's typically probably the easiest way to decide does something have an inverse or not, is to use the horizontal line test. That's usually the fastest way to go about doing it. Now the challenge comes in when we start looking at all the different things we've tackled this year. And I think about the polynomial chapter, which is the third unit we did. And that's where we learned about the x cubed, and we learned about the stuff. And sometimes we had the nice, pretty disco graph like that. That was nice, short, and sweet. But then sometimes we had the snaky graph, where it came up from the bottom, curved back down, curved back up, and finished up in the sky. Now, even though that was an x cubed graph, technically that version of the x cubed graph wouldn't have an inverse because it would fail at some stage the horizontal line test and stuff. So that big, when you start seeing x cubed with a bunch of other x's in the problem, it technically doesn't have an inverse. Still a function, it just doesn't have an inverse that can be calculated, is what ends up happening. And then that's where, like, my kids, and I'll draw it up on the screen. My calculus kids, as they were doing things and they forgot about it, is the function they were dealing with was x cubed minus x. And they asked us to find the inverse function and so forth as we were doing stuff, and the derivative of the inverse function. And when I think about this graph right here, that's x times x squared minus 1, which is x times x minus 1 times x plus 1. And then now when I go to sketch that graph of that thing right there, I have zeros at x equals 0, x equals 1, x equals negative 1. So negative 1 I cross, 0 I cross, and at positive 1 I cross. My leading coefficient is positive, so I start down here, go up, curve back down, go through the origin, curve, go back up through the other 0, and there's my graph. And then when I look at it, would that graph fail the vertical line or the horizontal line test? You betcha. Not at the very end, but eventually as we get closer to the x-axis, somewhere in there between the max and the min, we're failing. Okay? And that's why I was telling my kids, I was like, hey, listen, because they wanted to solve for the inverse first. I said, you can't. I said, it fails the test. I said, so we need to use the calculus procedure to get to the answer that they want you to get. That was numerical and stuff. You have to do that process. You have to ignore this training that we learned in Algebra 2. Okay, let me find the inverse and then do what I need to do, like calculus with it. Don't worry about doing that. Don't find the inverse function. We just go straight to the calculus. Okay? So, again, my whole point about that is that this stuff just keeps up in more and more other mathematics. So they explain again here the horizontal line test, if I didn't make myself clear. So now, how do you find the inverse of a function? So here are my steps for finding the inverse of a function. Step number 1. Replace f of x with y. That's your first step. Nice, super easy. All right. Step number 2. Switch x and y. You just switch them. Step number 3. Now solve for y. Which means I'm doing a whole bunch of inverse operations depending on how crazy my problem is. And then step number 4, replace y with f to the negative 1 of x. F to the negative 1 of x stands for the inverse function. It's the notation we use for inverse function. And you're going to see it in your homework problems as you're doing stuff today. Okay? So you want to make sure, okay, what does f to the negative 1 mean? It means the inverse function. What's coming next after the equal sign stands for the inverse function of some other function. That's the notation we use. So those are our steps. Now, the lengthy part is step number 3, depending on how big of a problem we're dealing with. Now, they can't be too big. Okay, we can't have a ton of x's in there. There's sometimes, and I have some picked out, where the x is in there a couple times, and that's okay, because the power arrangement makes it okay. All right, so So I have some problems set up here for us to solve together. Again, you're always more than welcome to work ahead of me if you want. But here we go. I'm going to do problem number 1 first. So problem number 1, first thing we're going to do, I'm going to take that equation and say y is equal to negative 3 plus 1/2 x. There's step number 1. Get rid of that f of x notation. That's just because it looks like crazy to me. Step number 2. So that's step 1. Step number 2. I swap the x and y. So I rewrite this as x equals negative 3 plus, sorry, I put my plus up too high, plus 1/2 y. That's step number 2. I just swap them. Now, step number 3, I have to solve for y. So I'm going to add the 3 over. I get x plus 3 equals 1/2 y. And then now I'm going to multiply both sides by 2. That allows me to cancel the 1/2. And I get y equals over here. I'm going to go ahead and distribute that 2 in and get 2x plus 6. And then now that I have y by itself, I replace the y with f to the negative 1 of x. And I now have the inverse function. I now have the inverse function. Going over to number 2. Easy one over here. Number 2, first step. Y equals negative x. Step number 2, swap them. X equals negative y. Step number 3, start solving. Divide through by negative 1. I get negative x equals y. I replace the y with f to the negative 1 of x. And there's my answer. Now, what looks a little weird on that one? It's the same thing, isn't it? Yeah, I mean, and again, that is just a quirky coinkydink. It doesn't happen all the time where it's the same thing that you started with, okay? But you know, typically it's some different. It has all the same numeral stuff in there. Just sometimes we see the different operations attached to it. That's the one example of. Well, actually, the other example would be like if it was f of x equals y is equal to x. Because then I'd say y equals x. Swap places. Hey, it's already solved. Y is equal to x. No, when on the step number 2, you just swap. You don't bring the negative with it. When we say literally swap, it's just trade places with the letters. Is all you're doing. It's a flat out swap. Okay. Did we tune me out? The f to the negative 1 is the way we indicate it's the notation that it's the inverse function. Well, I guess G, sorry. Yeah. I'm sorry, usually I always have these as F, so yeah, it's G with negative 1, yeah. I didn't see that they had G in front. So, sorry. I'm used to just F as F, so yeah, technically it is a G. Technically it is a G. All right. I would have saved my eyeballs. We're looking at the next one there, and I saw the F, and so I was just staying with that one. So, want to try number 3 by yourself? Try number 3 by yourself. There's a couple different ways you can tackle it, but you try it. All right, staying with those steps. Y equals 3/4 x minus 3/4. Swap. X equals 3/4 y minus 3/4. And then now I'm going to add the 3/4 across. I get x plus 3/4 equal to 3/4 y. And then now I need to get that off. So now it depends on if I want to get it off in one step or two step. Do I feel like doing like country dancing? We're going to do one step because we're big kids. So that gives me 4/3 times x plus 3/4 equals y. So we did use f of x. So f to the negative 1 of x is equal to that. So that's one way we can write our answer. Now, we know sometimes they want us to simplify. So to simplify, I would distribute the 4/3 and get 4/3 x. And then what is 4/3 times 3/4? Yeah, it's 1. Yeah. And that's how typically it'd probably be on a like the ACT. That's how it's typically going to be. I should have used that color yesterday. That was a better green. Wow, it always looks great on my iPad. It doesn't look great up there. It looks like a lime green up there. And back here, it looks like a nice St. Patty Day green. So that's typically what we're going to see for like an ACT answer. We're going to see it like that, distributed through, is what we're going to see. Now, did anybody start different when they moved the 3/4? Anybody do something different? What'd you do, Landon? You multiplied.
I didn't add it first.
You multiply by 4/3? Okay, yeah, that'd be fine. Another way you can do this one if you wanted to, on this step here, since they both have the same bottom, I could rewrite this as x equals 3y minus 3 over 4. And then I could just say, all right, let me multiply both sides by 4. And then that gives me 4x equals 3y minus 3. Add the 3. 4x plus 3 equals 3y. Now divide everybody by 3. Crazy 3 there. And that gives me 4/3 x plus 1 equals y. So I could do it that way too if I wanted to. Or yes, Landon, what you did was fine. Multiply by each thing by the reciprocal of 3/4. And then that works out fine. Okay? More or less, you gotta do what comes to mind, is what you need to do. What do you feel comfortable doing? And that's what you need to do. If you don't feel comfortable doing, there's a couple different approaches. Okay? All right. How can you tell if two functions are inverses of each other? I guess it didn't like me not putting a space between those two things, huh? First off, to determine if two functions are inverses of each other, we do the following things. First, we're supposed to check if the domain of one function is the same as the range of the other function. Second, we check if the range of one function is the same as the domain of the other function. Then we check this next part here. When we do our composite functions, if f of g of x is equal to the letter x, and g of f of x is equal to the letter of x, if they both work out to be x exactly, then they are inverses of each other. Yes, dear? You may want to take a picture. Lasts longer. Saves you time, too. Addie's the only one that has this one, right, Addie? I think hers is on there because I realized when I was cutting and pasting and putting it in my notes, I was on her notes section. I made sure I distributed stuff out. So. So good. So she had the benefit of it. I haven't already done so. Take a picture and import it in there. Put it in there. So we are going to be using, as we look at this next part, we're going to be doing this last thing, step 3. We're going to be doing step 3 for the remainder of class because that's going to be the more challenging part. Okay? We have to do a composite function. We did composite functions before spring break. That's what the break was. We've had too many breaks. We've had fall break, we've had Thanksgiving break, we've had Christmas break. But now it's spring break, so too many breaks. So both of those, f of g and g of f, they both have to simplify to exactly the letter x. If they don't, then they're not inverses. Okay? So, for example, here's number 1. I'm going to pull it up over here on the side to have more room to write. I got a test is f of g of x equal to x, and is g of f of x equal to x. So I'm going to do the first one. My f of x equation is 1/2 x plus 3/2. I now put the g equation in there. So 1/2, I put the g equation, 4 minus 3/2 x plus 3/2. I now need to simplify, I now need to simplify that to see, does it work out to be the letter x as an answer? So now I'm going to distribute the 1/2. I get half of 4 is 2. Half of negative 3/2 is negative 3/4. And then x on there. And then I have plus 3/2. And then now we go through and we simplify. 2 plus 3/2 would technically be 4/2 plus 3/2 is 7/2 minus 3/4 x. Well, here I can probably stop because how many x's do I see in my problem? 1. And is the 7/2 going to cancel out the negative 3/4? No. So we can say these are not inverses of each other. So these are not inverses of each other. And I can go ahead and stop because I didn't get x. And that doesn't simplify to x, so I can go ahead and stop. I don't have to test the g of f of x. Once one of them fails and doesn't become x as a simplified answer, you can stop and say that they're not inverses. Okay? You don't have to test both. The only reason you test both is if one does work out to be x, then you got to test the other one. All right, so let's do number 3 because we're on that same side. So I'm going to start with the f of n. So my f of n is negative 16 plus n over 4. So now f of g of n, again, my ultimate goal, does this work out to be the letter n, is negative 16 plus 4x plus 16, 4n plus 16 over 4. So I've now substituted in the g equation and for the n equation, or the n variable in the first equation. Now I simplify. All right, so that's negative 16 plus 4n plus 16 over 4. The 16s cancel. I have 4n over 4. Ooh, that works out to be n. That's a good thing. So that's great. Now I'm going to, since that worked, I got to test the other one. Now, since that worked, I go and say, okay, is g of f of n equal to n? Now I have to test that. So I start with the g equation, which is 4n plus 16. Now put the f equation in for it. So 4 times the fraction of negative 16 plus n over 4. And then the plus 16 is after the parenthesis. And then now I simplify. What do the 4s do? They cancel. So that leaves me negative 16n, 16 plus n. Sorry, 16 plus n plus 16. Negative 16 and a positive 16, they cancel each other. And I'm left with n. So we get to go up here and say, yes, these are inverses of each other. And again, the reason why, when I did the function composition both ways, put the g in for the n in the f equation, put the f in the n of the g equation, both ones simplified to be the letter n. That's why I know that they're inverses of each other. Okay? It's not a fast process. Okay? Really easy to make goofy, silly algebra mistakes as we're doing stuff. Okay? Kate and I'd stay away from doing it in your head. Is what my recommendation for you is. I know you like doing the stuff in your head. I'd recommend not. Okay, especially when they get more crazy looking, like number 7. But before we do 7, let's do 5. Let's get a cube. Let's get this cube power one in there. All right. So, I'm going to start with the f. Negative parenthesis n plus 1 quantity cubed. Now I'm going to put the g in for that. So negative parenthesis 3 plus n cubed plus 1 cubed equals, all right, let's see. That's a negative. All right, so this one I'm going to go ahead and stop. Because when I did any of the combining of stuff and I got to that stage right there, I realized there's nothing going to cancel out. There's no way that's going to simplify down the end. Because technically what I'm supposed to do, and we did this already this year, I'm supposed to take negative n cubed plus 4 cubed and say negative times n cubed plus 4 times n cubed plus 4 times n cubed plus 4 to start simplifying. Now, I don't need to do that because we know what's going to happen when I do n cubed times n cubed times n cubed. I'm going to have technically out front n to the what power? 3 plus 3 is 9. Okay? When I FOIL multiply that out, this ain't going to go down to just an n. So I can go ahead and stop at that stage and say, hey, these things ain't inverses of each other. Okay? So now where I would keep in mind, now can we do that again, ACT tip. All right, not an EOC tip, but ACT tip. I should be able to tell from the original functions, I got a cube, they're not going to cancel. What cancels a cube? A cube root. Okay? So when I have these two things and they're both cubes and say, are they inverse? They ain't going to be inverses of each other. The only way you're going to cancel a cube is a cube root. Okay? Yeah, it would have to be like, let's say they had the cube root of 3 plus n, and then we would be able to stick that sucker in there, and that may be okay. Okay, so. And we have some that are like that. So, again, we can use some common sense as we do things. All right. Now, here's where we got to be careful, like on number 7. Looking at it right off the bat, what do we notice about the denominators? Totally different numbers. One's got an x minus 3, one's got an x plus 3, but we shouldn't just rule it out because that looks different. Because sometimes when we combine terms, we get different things. Okay, so I mean, again, I should go through. I'm trying to decide which one I want to do. I'm going to do h of f first. I'm going to do the opposite, h of f. negative 1 over, and then now I get to put in 4 over negative x minus 2 plus 2, and then it has a plus 3. All right, sweet. So that's going to be negative and then 1 over 4 over negative x minus 2 plus 5. And then now, let's see, Mr. Stevens, negative 1 over, I would have to basically multiply this top and bottom by 5. And then this, put it over 1 and multiply it top and bottom by negative x minus 2. And then that would give me, that's 5. So that gives me 20 over negative 5x minus 10. And then we have plus negative 5x minus 10 over... I didn't have to do the 5 there. I just had to do x minus 2. I made it too big. Oh, you doofus. I just had to do x minus 2. That part. I just had to multiply the right side by it. That's a doofus butt. All right. So that's all I had to do. I just had to multiply the other side. All right. So now I get to combine those and say negative 1 over 4 minus 5x minus 10 over negative x minus 2. And let's see, this technically gets to go to the tippity top. And so we have a negative, and then it's negative x minus 2 over negative 5x minus 6. And then this is where I would officially stop and say, okay, that's not going to work out. This is when I would stop, and we would say, not inverses. All right. I had to keep going just in case. But I got to finally a stage where now when I look at stuff, there's no way that's going to simplify out to be just an x. Is what it's going to end up being. Okay? So you can get lucky, but we don't want to be getting lucky. We got to make sure we can do stuff. So real quick. Homework should go live. Remember, it's an Edge Elastic. We'll do an entrance ticket tomorrow. It's not going to be super crazy. All right. This was from a worksheet that I got off the internet on Algebra 2 level for solid flow stuff. So it wasn't like me taking like pre-calc stuff. So as always, if you have questions, holler at me. It just takes some time.